Okay, folks, welcome back to Swift on Sundays. My name is Paul Hudson, and as usual in these sessions, we're going to try and build a complete app from scratch. The goal's usually about an hour, sometimes 90 minutes or so, but it varies, obviously, depending on how many questions you ask in the chat window. Today, we're going to build an app that uses ARKit and SceneKit and Codable all at the same time to bring something together that's new and useful. I think roughly you're looking at about 150 lines of code. Obviously there's some white space and so forth, but about that is what we're looking at, all in, which is quite nice, I think. I should say, you're going to need a physical device for this, because if you want to follow along, you have to have a real actual device that supports ARKit, right? That'll mean, an iPhone or an iPad, bluntly. Now, I did test on my 10s Max, and there were problems, because it looks like core motion's a bit glitchy here and there on the iPhone 10s and some iPads. So if you see random core motion crashes while your app carries on running, it's an Apple problem. File a radar is all I can say. I found it works great on my iPad Pro. This one here. We'll be using that today. Now, as we did before with one of the games we made in SpriteKit, when we have to use screen capture, I'll be sort of mirroring my physical iPad on the screen capture screen you'll see in a minute. That plus camera plus streaming plus who knows what. There's a variety of ways this talk can go wrong. So we're going to see how well this works out. I'm kind of hoping the best. Anyway, we've got stacks to do. As a reminder, I don't have many rules. The ones I care about are 0 tolerance for harassment, instant lifetime ban for harassing or discrimination or abuse in the chat window. Please don't do that. Second, if you have on-topic questions, if you're saying, Paul, why are you doing that thing rather than this thing? That's an on-topic question. Go ahead and ask that straight away. I want to know about those. I'll do my best to answer in the chat window, minus some, lag time and similar. And then if you have off-topic questions, i.e. everything else ever that is not directly what I'm doing right now. What is my view on Flutter? What do I think about UIKit? What do I think about Dub19? Whatever it is, ask those at the end. Otherwise, it's just an epic, constant speed bump for me. So please do on-topic questions as you see them, off-topic questions at the end. That's pretty much it. So I'm going to go ahead and try and share my screen, and we'll see whether I can get that plus screen sharing, plus recording, and the camera all to work at once. So I'll go ahead and share my screen, see if this works. Okay. So all being well, you can see down here in the bottom corner, that is my actual iPad running as a screen mirror using QuickTime. That's this thing here. You can sort of see it at the same time. There we go. Boom. That's that running from QuickTime. And hopefully you'll see also the chat window on the right while I see your questions, all being well. And the Xcode on the left. So we're going to just dive in and try and make our project and see where we get to. To kick off, go ahead and choose Create a New Xcode Project. And when its big old window appears, which is done over here, unhelpfully, there we go. I would like to choose an augmented reality app. Make sure content technology is set to SceneKit. You can use SpriteKit or Metal. In this case, I think SceneKit works best, as you will see. And then for product name, we're going to call this thing Spot the Scientist. And what's going to happen is I have prepared a series of pictures of scientists. You can try and guess them if you want to. Everyone should know this dude all being well. That's Albert Einstein. We have here Ada Lovelace. This is Marie Curie. We have Nikola Tesla, and we have Mary Anning and more. I prepared a series of pictures for us to work with, and they're all well-known scientists from history who've done various things: mathematics, geology, physics, biology, whatever. We're going to use those to have ARKit detect those and tell us more information about those people. So I want you to go ahead and call this thing Spot the Scientists with SceneKit, press Next, and save it on your desktop. That's fine. Have a little think. Go on, Xcode, you can do it. There we go. Okay. So, what we're going to do is first clean up the template, because Xcode's template for ARKit is not terrible, but it's not great either. You've got to go ahead and zap this thing here, art.scn assets. This gives you like a little airplane, which is completely pointless. So scrap that thing, move to the trash. We don't want that at all. And then in view control Swift, we'll do a little bit of cleaning here. Not much. It's basically okay. Look at the way they arrange their imports, reverse alphabetically, just to annoy me. Anyway, in here we can get rid of things like statistics can go, this scene can go, InView load. Then all these empty delegate stub methods here, these can all go. We don't want any of these things down here. I'll just scrap all that code like that, leaving a fairly slimline viewcontrol.swift file. And that's enough for now to work with. Now, like I said, we're going to point our device, the camera of my iPad, or point that thing at various scientists and get information about that scientist from them. So I've prepared for you some assets to use in this project. Now, if you're following along with this later on, not in the live stream, these will be on the GitHub, which is github.com/twostrawss/SwiftOnSundays. Grab the code from there, or grab the assets from there. Here, for people who are doing the live stream, I'll just send you a zip file into the chat window. So you can grab that zip file and I'll walk you through what's actually in there. I'll paste that into the chat window like that. And I already have that on my desktop. If I move this out of the way, we'll see scientists here. And this is packed out with stuff for our project. So you'll see again, people is the pictures of people I want to recognize. And there's Mary Anning, there's Marie Curie, it's Charles Darwin as well, Einstein, Galileo, Lovelace, Newton, and more. Famous scientists from history. You'll also see those same pictures in a PDF called scientists.pdf, laid out in a 3x3 formation like that. And this is so you can print it out, because obviously you need some actual physical real world stuff to work with. That's the nature of AR, it's augmenting reality. So you'll print those PDFs out and you end up with the same thing I have, these little sliced up people pictures. It's like top trumps for scientists, like that. So you print that out using your printer. It can be black and white if you want to, doesn't really matter. As long as you have those pictures plus the same pictures in your actual project to work with. So that PDF matches those people. You'll also see flags where I've printed out, I've got images for Germany, Italy, Poland, Serbia, and UK. Those are the places those scientists come from. So, Louis Pasteur, and actually he's French. Maybe I didn't include Pasteur by accident. Whoops. Serbia, okay, Tesla's Serbian, he's fine. Or Poland is Marie Curie, or Italy, Galileo, and so forth. I'll fix that in the GitHub repo, don't worry. So we have the flags, we have the people pictures, and last, we also have this scientists.json file, which contains descriptions of the scientists and what they've done. So you'll see here, it says, Mary Anning lived on these dates. She was known for paleontology. That's her bio. It's like the first line or so from her Wikipedia page. Which country she's from and where I got that stuff from, like a credit line, basically. Same for Marie Curie, Charles Darwin, Galileo, and so forth. It's all here. The same thing each time. A one-line or two-line description of who they are plus their country. And these countries match up with the countries in the flags thing. See, Louis Pasteur isn't in here. That's why he's not in the pictures of flags, you see. One for you to later on, perhaps. Anyway, so it's just we've got some basic data to work with, but we want to show that inside our app after we've done image recognition. So we've got lots of stuff. So step one, obviously rather hard to do live, but if you were doing this later on, step one, go ahead and print scientists.pdf, ideally in color. If not, black and white's fine. Just make sure the people pictures you add to Xcode are also black and white. Print that out, slice it up into small bits like this one that you haven't all done. Then you want to add these flag pictures. Here, I've got 5 of them, but if you have Louis Pasteur, you'll have 6. Add those to assets.exe assets, to your asset catalog. I'll drag those in. We can reference those as pictures in our work later on. Then we want to say, add these people pictures Mary Anning, Curie, Darwin, Einstein, and similar. These are special pictures. They're not just asset catalog pictures. They're things we want ARKit to recognize. They're special pictures. And so what you want to do is you want to right-click in your asset catalog in this big space here and choose New AR Resource Group. And then drag the pictures where it says here, drag and drop to create add new AR items. I'm going to drag all these JPEGs from the people directory into that resources directory, like that. And I'll add them all in. Now hopefully you'll see a little warning in a second when it has a little think about the pictures. Let's find out. It's validating them now, which is very helpful. Once it does that, we should see some warnings for being well. There we go. Okay. So what Xcode does for us is very clever. It has looked at those pictures to decide whether they are good enough for ARKit to recognize. And that means, for example, if you try and recognize solid colors, like just reds or blues or like simple flags, ARKit can't handle that. There's not enough texture detail in there to work with. Similarly, if you have lots of texture detail but not much range of brightnesses or colors, if the histogram is very one-sided, then ARKit will do a bad job recognizing it. In this case, it's warning us, the pictures are okay, but it's telling us what size are these things. Because for all it knows, this picture of Charles Darwin could be 8 meters by 10 meters, right? It's got no idea how big this picture is. And this matters because ARKit thinks in physical space. It's able to estimate very clearly how big things are in a physical space. And so by telling it the size of these things, it'll be able to recognize, yes, that's that particular picture of Darwin. That's this Tesla picture here, not a huge wall-mounted Tesla picture. That's just too big. So I'll tell it the size of these things. So I'll go ahead and select all these pictures, and I'll put the inspector here on the right. And you'll see it has a units and size option. Now I'll change units from meters, which is the thing SpriteKit and SceneKit love working in, to centimeters, like that. And I'm going to say the height of these pictures is 8.58 cm. And they are. I mean, I made that PDF document. That's I know exactly how big they are. That's how big the pictures you should print out are. Now you'll see it fills in the width as well as 5.9459 width. It can do that automatically because it can look at the size of this thing and say, well, if that's 8.58, then the width must be the pixel width divided by the height. So it can figure that out dynamically based on the height value alone, which is great. So these are the pictures you want to look for. And these are grouped together into one AR resource group. Now ARKit's capable of recognizing, I don't know, about 20. I don't think Apple say a specific number, but it's about 20 pictures at a time from a single AR resource group. So that's one of them here. And we're going to say this resource group is called scientists. So if you have multiple one of these groups, you'd name them appropriately. For example, you might say, you know, in the Louvre or the National Gallery in London, you might say, here's one room, here's another room. Just group them together intelligently like that. So now we have our scientist pictures added to our asset catalog, ready to go. So the first thing we're going to do is tell ARKit to start scanning for those pictures. Just look around the room to try and find those pictures. So I'm going to open up viewcontroller.swift and get rid of this sidebar again. And you'll see by default in view will appear, we have an AR world tracking configuration. This is useful for when you want to look around with your iPad and try and find things in the real space. You want to like place space invaders or targets around the place, try and find those things in your game. Question from Maria, what if the warning didn't disappear? You'll have to read what the warning is then and tell me what the warning is, because you can see my warning disappeared just fine. But yes, obviously it depends on the warning. You can actually click on the warning, it'll tell you what it is. It should give you an idea of, oh, your picture isn't good enough, or it's too small, or the size isn't right, or whatever. Anyway, so AR world tracking configuration is when you want to place like a piece of IKEA furniture in your space. It's not great for image tracking. That's not what it's there for. So we're going to change this thing from AR world tracking configuration to be AR image tracking configuration. And that is optimized for finding images in a 3D space and letting us work with them. So now we have that, we're going to load our images from the asset catalog and assign that to ARKit and say, hey, these are the things you should be looking for. So we'll say guard let tracking images equals an AR reference image dot reference images in group named, like that. And my group's called scientists. And the bundle can be nil, which means the default bundle here. If it's the same warning, Maria, it means you haven't set the width and height correctly. If we can't load that for some reason, I'll say fatal error, message, couldn't load tracking images. So we couldn't find them for some reason. It should never happen. Just bail out immediately. With that done, now we can assign those to our image tracking configuration. We'll say configuration dot tracking images equals tracking images, like that. So there's not a lot of code here so far, right? And what we'll see is we're basically saying, give me an image to work with, like that. Then assign that to be our tracking images. Now again, you've got to be really, really careful here because ARKit does not like to work with many pictures. What you'll find is if you have, again, Apple don't publicize the number. I don't think they say what it is. I think it potentially varies from device to device. What you'll find is that at about 20, it will start to succeed or fail fairly randomly, beyond 20. I've done 20 just fine. 25, 30, it gets hit and miss. And in particular, again, this is super device dependent. Like a 10S will do, I think, better at this than a 10, will do better than an 8 and similar. The number of things you show simultaneously will also vary. So for example, if you want to say, here's Mary Anning and Nikola Tesla and Albert Einstein at the same time physically being detected, it might do it, or it might not. And realistically, I don't think Apple actually tell you what the limit is. They just say, we'll recognize 2 or 3 at a time, but it's not hard coded. So they're leaving flexible room there to kind of grow over time. So what we're going to try and do now is we'll detect one of these things at a time. Like I said, it's flexible how many can be actually detected, but for now, we'll just kind of go with all of these things and just see what we can kind of get away with. Otto, we're making a ARKit app that detects pictures on my desk using an image tracking configuration. And then we'll kind of see how that works out. Anyway, so we're going to go ahead and write just enough code to detect some sort of picture just to prove this is all working correctly. It won't do very much right now. In fact, I'd say it's pretty boring, in fact. But it's enough to get us started. So what you'll see is, by default, our scene view we are the delegate for the scene view, which means when the scene finds something interesting, it'll ask us what to do with it. And in ARKit land, what you'll find is it'll say to you, here is an anchor. Here's something I found in the thing that I recognize, that I care about. And it might be something we've placed or something it's detected. And it'll say, okay, here's my anchor. What SceneKit node should go there? Or if you're using SpriteKit, what SpriteKit node should go there? And we can decide what we do with that. For now, super simple, just to prove that it's working, we're going to try and color the picture blue. We're going to try it, see how this works. I'll make a new method here. This is called node4. And the full thing is, here's my renderer, here's an anchor. What is the node for that anchor? And it's return an SCN node optional. If it is nothing for that, we don't care about it, just bail out, fine. Otherwise, give me back an actual SceneKit node we can render on the screen. So what we're going to say is, in our code, first, try and convert that AR anchor, which could be something we've placed, or something that's been detected, to an image anchor, i.e. an image from our resource catalog that was detected. So we'll say guard let image anchor equals anchor question mark as AR image anchor, else return nil. So if we couldn't find that thing as an image, we don't care about it. It's not part of this program, it's something else entirely. And it is whinging already. Oops, sorry, anchor question mark, sorry, as question mark, there we go. So try and convert to an AR image anchor like that. Next we're going to say, make me a SceneKit plane. A plane is a two-dimensional object with a width and a height. There's no depth to it, it's the width and the height. placed somewhere in the scene. And remember, you've got to think now in scene coordinates. You know, these things are what? Is it 8.5 cm high or something? We want our node also to be 8.5 cm high by whatever wide it is. And we can do that by asking ARKit to just tell us the size of that image. So we'll say our plane is a new SCN plane, that's SceneKit plane. This has a width and a height parameter. We're going to say the width is our image anchor dot reference image dot physical size dot width. So however big the image was being added, that picture, that's how big our plane should be as well. And the same thing for height. So we'll say height is image anchor, reference image, physical size, height. Boom, like that. Now for testing purposes, just to prove this actually works correctly, I'm going to say the plane has a material, which is the thing attached to a texture or a color on this thing. We're going to give this thing a color by saying it has a diffuse color of UI color dot blue. So a bright blue glowing color attached to this plane. And this thing, dot content, sorry, not color. This thing takes literally anything. If you look at contents again in code completion, you'll see it is an optional any. You could pass this whatever the heck you want, and you'll see it supports things like NS color, NS color, UI color, all sorts of things are supported by this property. It's really, really flexible as a way of drawing stuff. And as I say in here, there we go. Numbers, images, URLs, strings, videos, textures, other scenes, and more. It's really, really flexible what it takes. We're just saying, just make it blue, okay? Keep it real simple for now. Just make this thing blue. So that is a plane in our 3D geometry. What we want to do is wrap that in a node. This is the equivalent of a UI image and a UI image view. The plane is just some reference data, right? It hasn't really got a position or we moved around the screen. We're going to put that inside a node. We can then move around the screen freely. So we'll do that now. We'll say there's a new node called plane node. And that is a new SCN node with the geometry being our plane. So it's equivalent to saying a new image view with our image inside it. That's what we're saying here. Now that node, we're going to return that from this method. Return the node. But we don't want to say directly return plane node. And the reason for that is fairly simple, because when that gets sent back, it'll be attached to the AR anchor. You imagine there's an AR anchor in memory somewhere, it hasn't got a physical representation. This node becomes the physical representation of that anchor. If that anchor is, here in 3D space or here, wherever it is, SceneKit will draw this node at that location. And as that anchor moves around, the node will also move. The node will follow the anchor in 3D space, which is awesome. It's really, really cool. But if we return the node directly, it'll be positioned like this, face up, looking towards us directly. What we want to do is say, actually, I'm looking down at my desk. I want to spin this thing around so it's face down the way. And if we do that, now when it tries to move around the screen, it'll be moving around spun. It'll move entirely the wrong direction because we've rotated this thing. It'll move wrongly. So what we want to do is make our node, where our plane is, spin it around so it matches the orientation of our desk I'm working with, then attach that to a new node that can move around in the original coordinates. So the whole thing moves around exactly as the anchor intended and not on its rotated angles. A bit mathematical, I'm sorry, but that's just the way SceneKit works. So we have our plane node here with our geometry inside it. What we're going to say is first, let's spin that plane node around. We're going to say it has an Euler angle x of minus dot pi divided by 2. So 90 degrees that away, basically, to make it flatten out on the thing. We'll then make a new empty SCN node, like that. Add the plane node to that by saying node add child node plane node, and return that empty node, like so. So that empty SCN node will be moved around freely to follow the anchor in 3D space. And inside that, our plane will stay fixed horizontal like that. So it won't affect the way movement happens. So that is, I think, in theory, all the code we need to get started. Let's find out if this is going to work or not, because there's so many possible places this can totally screw up. Let's find out. So I'll make some space. Let's unlock my iPad. And let us try running the code on Jops, my iPad, and see if this thing's going to work. Because, you know, lol. Otto, I learned about 3D stuff a long time ago when I was doing DirectX 8 on Windows. I had no idea. When I came to it first, I had no idea. I thought you moved in 3D space using some modified Pythagoras theorem. I had no idea what a matrix was. All right, so I want to read the camera. Fine. Let me try and bring up this window here. Yes, access the camera. There's my desk. And here, boom. You see that? If I cover it up again, there we go. You can see there Nikola Tesla. As it gets enough to recognize him, it kind of goes blue. It's got enough to recognize who it is. Like that, you see? Fantastic. And this thing moves around in 3D space, as you expect. Boom. So it follows him around nicely. That's what it does. If I bring in, let's do, here's Marie Curie. You'll see it tries to do both. And it's having a go at doing both, but not doing really well. Bring the other one in, it's kind of struggling to do two at a time. I think the iPhone's better at this than the iPad, personally. Yeah. So you see it's trying to do two and basically failing. But I think if you use an iPhone, sorry, you'll have better results. Anyway, let's head back to Xcode and stop running that. Boom. Okay, so that's actual progress. You can see it is correctly finding the image anchor, making a plane for it, attaching it to the anchor so as we rotate it and so forth. It follows it fully in 3D space. And you can, pick up your iPad and hold it around, turn it and so forth. It'll do a pretty good job of mapping that. There's a slight hiccup because we're using printed pictures. The way printers work, of course, they sort of put paper coming out the way. So you may find your paper, like mine, has got a curve. It does not like curved stuff very much. So if you have pictures from your printer that are curved, stick them under a book for a few hours or something like that, and it'll be better. Anyway, the basic part of our app's working. We have a blue plane appearing over our pictures, showing they've been recognized correctly. The next step is to load in that JSON I showed you, which is here, scientist.json. I'm going to go ahead and add that directly to my project by dragging it into the project navigator. Boom. I'm going to load that into a new scientist struct. So you can see it's a dictionary here. The key names are the names of the people. So Anne, Curie, Darwin, Einstein, similar. And so there are values like names, dates, field, bio, country, and source. And they're all strings. So I'll press Command N, make a new Swift file. Choose Swift file. Call this thing scientist. Boom. I'm going to make this thing a struct called scientist that is decodable. Codable. And it's got various properties. We'll say let name, string, let name, dates, field, bio, country, source. All right, let dates, string, let field, string, let bio, string, let country, string, and let source, string. So those 6 fields are the ones that store one scientist inside our program, and we're going to load that using JSON and using Codable. So back in viewcontrol.swift, I'll add a property up here. We're going to say there is a scientists dictionary, which has strings for keys and a scientist for its values, like that. Boom. Okay. Have you a little think? There we go. Okay. So now we can load this thing from JSON using Decodable. And there's nothing fancy here whatsoever. I've done better versions of this previously. Watch previous episodes of Swift on Sundays for that. We're going to do a dumb version here. Sorry, a simple version here. We're going to say func load data guard let URL is bundle.main.url. No code completion for me. There we go. There we are. For resource, it's called scientists. with extension JSON, else, fatal error. Oops, I should have turned that thing off, shouldn't I, really? So I turn my iPad onto flight mode, perhaps, to avoid notifications. Anyway, fatal error, unable to find JSON in bundle. Boom. Then guard let data is optional try data content of that URL, else fatal error, unable to load JSON. What are you saying here? M7MD videos. No, I was pretty clear. 6 p.m. BST. We are in summertime now, I'm afraid. That's our data. We'll now decode that. We'll say let decoder equals a JSON decoder. And then guard let loaded scientists equals try question mark decoder dot decode. It's a what? It's a dictionary of string scientist dot self from that data, else fatal error, unable to parse JSON. Boom. And finally, phew, scientists equals loaded scientists. See that all works correctly. Come on, let's go. You can do it. It's very slow building today. 10 seconds, wow. Anyway, so obviously Codable saves us lots of time, but it's still quite a lot of code. I apologize for that. Anyway, that's going to load our data into our scientist dictionary. So I'll go ahead and call that thing from view.load. We'll say load data. Boom. And now we can update our node4 method, this thing here, so we recognize which scientist it found. Because right now you just see a blue box, could be any scientist. We want to use this point to look up that scientist that was found and print out their information. We'll do more in a second, but just for now, to prove it all works correctly, we're going to print out their information. So under this guard here, we're going to say guard let name equals image anchor. Come on, code completion. Anchor dot reference image dot name. So what's the name of the image that was found? If that isn't working, we will return nil. Now this reference image name, if you look in our asset catalog again, you'll see it's called Anning, Curie, Darwin, Einstein, and similar. That's the name of these images. You see, name here is Curie, name is Lovelace, and similar. By default, it's the file name of the picture. So we added lovelace.jpg or pasteur.jpg. That becomes the name of the reference image. So if you want different names, by all means do. I've named it so the names of the pictures match up with the key names in our JSON. So Anning matches here, and Curie, and Darwin, and similar. Those pictures we added become the keys in our JSON. What that means is, once we know we have an image name here, we can go ahead and find that scientist using our dictionary. We're going to say guard let scientist equals scientists name else return nil. So to attempt to pull out the scientist we found based on their name, we can't, bail out return nil. And at this point, we can go ahead and do stuff. We'll say print scientist dot name. My code completion is getting really slow today. Name and bio will do. Otto, how I started coding slower because you couldn't keep up at all. That means you're getting better, I think. You are improving, your Swiss skills are getting faster and faster, which is great. Anyway, I'll go ahead and press Command R to run my code again. And let's try and detect another scientist. This time we should see something in our output logs here. I'll make this a bit bigger. Boom. So, I'm going to bring in, there we go, Ada Lovelace. And you'll see Ada Lovelace, Augusta Ada King, Countess Lovelace, da 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 da. Boom. Right there. And let's try out Einstein. Boom, there he is, German-born theoretical physicist. Yada, yada, yada. Let's do Curie again. There we go. Fantastic. So, it is now, you're seeing the blue shape thing, which is great, but you're now also seeing it knows who it's detected and letting us pull it out from our dictionary so we can start using that information somehow. Now for the important part. We want to actually start overlaying stuff into our 3D scene. So it starts becoming more interesting, because right now, it's not interesting at all, let's face it. It's just a blue box, which kind of sucks, right? Before we do that though, I have an important request for you. Please go ahead. If you're enjoying this video, please like it. Please press that like button and subscribe to my channel. I work extremely hard to bring these videos to you free of charge every week when I can. If you enjoy them, if you are getting information out of them, if you are learning stuff, please like the video, subscribe to the channel. It does help more folks find my videos. So yes, your likes are very much appreciated at this point. Thank you very much. It's all appreciated. Anyway, with that done, let's go on to the real deal part of this project. We want to start showing text on the screen saying, we found Marie Curie, here's her bio, here's her flag, and similar. And I think you'll be pleasantly surprised this doesn't take much work actually. What we'll do first is add a couple of cheeky extensions, because by default, SceneKit positions things based on their center, just like SpriteKit does. And that's great for many things. I find it really annoying when I'm trying to do precision layout. I want to say, you know, this thing's to the right of that thing and similar. David King, thank you very much. When the dogs come in at some point today, they will get some treats from you. Anyway, I find it very nice to be able to say, this is to the right of that thing, this is below that thing, using the top left corner or the top center to do alignments and so forth. I find that a much more natural way to think. So I nearly always paste in some extensions to make that easier. So the first thing we're going to do is add an extension outside our class, extension on SCN node. And this thing has two methods and two properties. Properties are simple enough. We're going to say the first one's called width. What is the width of this node? Because that's not actually in there by default, right? You haven't got a width of the node, you've got a bounding box. And the bounding box stores a relative x and y compared to the parent scene. It's not very helpful. What we're going to say is this thing's a float, and it's going to return bounding box, the position of this thing, dot max.x, sorry, our maximum x position minus the bounding box dot min.x. So if min.x is 100 and max is 200, this will return 100 for the width. But there's a complexity here, which is that as we adjust the scale of our nodes, because they're nearer or further or smaller or bigger, whatever, this thing, the bounding box, doesn't change. It's normalized to the node's space, not to the world space. So as the size changes, the bounding box will not change. So what we're going to do is multiply this by scale.x. So figure out our left and right positions, multiply that by our scale, and that gives us the actual real world width of this object. We're going to do the same thing for height. So I will open that width and copy that and paste it below and call this thing height. This is going to be bounding box max y minus bounding box max y, min y multiplied by scale y. Same thing, just y rather than x. So those are the two properties, a width and a height, just to make our life easier. One of the dogs has turned up. David King, you've given her a treat. You have to recognize it. Come here, you. This one's from David King. This is our new dog, Aria. Come on, you. Oh, hello. Oh, the other one's arrived too. You get a treat. That's from David King. He likes you very much, clearly. Good girl. She's a very, very friendly dog, this one. Very, very affectionate. And likes treats very much too. Luna, you have to wait a minute, afraid. Sorry, sweetheart. You've got to wait a little bit. Right, anyway. Let's carry on without the dogs interrupting too much. The other thing I want to do is change the way we position our nodes. So we can say this one's positioned from the top left corner, so we can space it exactly right where we want it. But also I find it useful to have a top center, so I can center things nicely vertically. So I add two methods to my extension. One is called func pivot on top left. So position me from the x0, y0 being a top left corner, just like the way UIKit does it. I find that a much more natural way of working. So the first thing you do is figure out our min and max positions. We'll say let min max equals bounding box, like that. And that will decompose bounding box into two values called min and max. We can then make our pivot point where we position ourselves from a new translation, a new position. So we'll say pivot equals, there we go, SCN matrix 4 make translation. This takes 3 floats. In our case, it's the left-hand side. So we're going to say our min.x. So our left-hand side. For the y, we're going to modify this just slightly so it comes down below other things. So we'll say our max.y minus min.y, come on keyboard, you're failing me now, plus min.y, like that. Just push it down by our height. And for z we don't care, so there's a 0. Z's depth, by the way, we don't care, so just 0 is fine. So we've got min.x for the x position, max.y minus min.y plus min.y for the y position, and then 0 for z. That's top left positioning. Top center is very, very similar, like that. So we have, again, 0 for the z, which is fine. Yeah, sorry, top center, not top left. There we go. But this time the x is more complicated because we want to get this thing centered in our left and right position. So what I have to do is get inside here our max x minus our min x, so our full size, and halve that thing. Because we're already in, if you think the left hand side is the full side, the left side, the right hand side is the full width, half the width is the center, that's where we want to get our position from. I'm going to add to that our min x to push it along to the left. The middle part same, max y, and then 0. So that lets us position these things much more naturally. These two I nearly always, or these 4, sorry, I nearly always just paste into every project I do in ARKit because I haven't got the patience to do it by hand. Just copy and paste that code every single time because it's just easier to work with. Anyway, we can now pivot on top left and pivot on top center. The next job is to start laying out some text nodes. Who is a scientist and what's their bio? Lena, there's no point going back. There's no more donations yet. Sorry, you gotta wait. You gotta wait, Poochie. Sorry. So we're gonna try and position those things on top center and top left. And you'll see there's a big one for the person name, you know, Mary Anning or whatever, Albert Einstein, and then a much larger one for their bio. And because there's 2 of these things, again, I normally make a method to help me out because it's much easier to do it in one method. It makes your code somewhat shorter. So what we're going to do is we're going to make some space inside our view controller and make a new method. This thing is called text node. Make me a text node. And it'll take 3 parameters. One is the string we want to draw, Mary Anning. One is the font we want to use to render that thing. So it could be a bold, large one for the title and an unbold, small one for the bio. And then, what's the maximum width we want to place this thing into in coordinates of our world? And this will be an optional int with a default value of 0. So no maximum width by default, be as wide as you like. This is going to return an SCN node, which will be our text node. Now, SceneKit already has code in place for rendering text, and it's got a few weird options that will be completely alien to you at first because if you've never used SceneKit before, the way it does text is odd. Keep in mind this thing's being rendered as a 3D space, right? So that means it has to have 2 considerations. The first is how deep is this thing? What extrusion are we going to apply to the text? Because you might have like, you know, super wide text in 3D space. In our case, it should be completely flat, you know, 0 depth effectively. And the second thing is, how round should the characters be? Because keep in mind, this thing's being rendered into 3D space, which means polygons. It means triangles to render out every single letter. And while that's great, it's really powerful as all for us, there's a cost to that. If you think about having some very, very smooth text, means having lots and lots of polygons to draw that text, versus, you know, chunky, horrible text, fewer polygons. In this case, we have not got a large scene to work with. It's actually a very simple scene to work with. So we can have super smooth text and it's absolutely fine. But in theory, in more advanced games, we want to scale back the smoothness of the text a little bit, make it a bit faster. Anyway, in here, we're going to start making our text geometry. Again, that's like the UI image of this thing. It doesn't got a position, but it's got data. We'll say let text equals an SCN text object. And this has string and extrusion depth. Our string will be str that's being passed in. And extrusion depth, how deep to make it, we're going to use 0. No depth, just flat text on there. Next, we're going to say our text has a flatness value. So you can see this determines the accuracy or smoothness of the thing. Now, what we want to do is say, make this really not flat. Flat is SceneKit's way of saying, chunky, nasty, cheap polygons. We're going to say 0.1. Like, make this really not flat, really smooth curves around our text. That's what we're asking for here. Get the best possible kind of text layout. This thing wants a font, so we'll just do text.font equals the font that was passed in, like that. And now, we're going to say, if we have a max width passed in, if they said, don't go any wider than this, which we're going to do for the bio, then wrap the text inside that frame. So we'll say, if let max width equals max width, then our text has a container frame, the space to draw it into, and it's going to be a CG rect with the origin of 0, because left-hand top left corner, and a size of a CG size, with the width will be our max width they asked for, and our height some large number. So it'll just keep on flowing down and down and down. I'll say like 500 or 1,000. We don't care how many lines it goes down, just so it doesn't go wider than a certain amount of space. Like that. So that tells the text to draw inside that box. And then we'll say text is wrapped equals true, to make line wrapping actually happen inside that box. Again, that is just data. That's a model data, like an image. It's not an image view. We can't place it on the screen. That's done using a new SCN node. So we'll say let text node equals an SCN node with the geometry of our text. So another node with that text attached to it. And now what we're going to do is make that text node tiny, like really, really small. And the reason for this is because when we make text nodes using, say, 12-point font or 20-point font, that gets converted to the coordinates of SceneKit on a 1-to-1 basis. So a 12-point font becomes a 12-unit sized node. And if you remember, I said earlier, SceneKit loves meters. It adores meters. So if you want 12-meter high text saying Mary Anning, awesome. Absolutely awesome. Here, we don't. We really want tiny, tiny text, so it's in centimeters and millimeters rather than having huge, huge text. So we're going to say text node.scale is SCN vector 3. This takes 3 parameters, x, y, and z. And I'm going to use 0.002. So go down to like 0.05% of what you think it's going to be. Like that. Boom. So make the text way, way, way smaller. And this is effectively try and error. I found that for the fonts I'm using, that looks great in this particular application. And then we'll do return text node. Send it back once it's been made. So as you can see, there's quite a lot of work to make a string with a font. As you know, make the thing flat, wrap it correctly, assign it to a node, scale it down. And that's why I have this helper method, because I don't want to do that in every single piece of text I want to try and render. So now we're going to go ahead and expand our, so where is it? Node 4 method, which is, here it is. We're going to expand this thing to show text about the scientist that was made. So I'll make this thing not use blue anymore. That was just testing purposes. I'll use clear. Has no color inside there. But you can put it back to blue later on if you want to. And then print out the name, delete the print for the name and bio, like that. Instead, we're going to start laying out our things on the screen. So we have this plain node here. We're going to go ahead and add some code here to make stuff. The first thing I'm going to do is add a spacing constant. How much space to put between the picture and our title, the title, and the bio on the screen. And our spacing will be a float equal to 0.005. So a tiny amount of space. But remember, this is in meters. So that's a small amount of space in pure numbers, but quite a lot in SpriteKit terms, SceneKit terms, sorry. Okay, so now let's make our first node. We're going to say let title node is a text node using our method. This thing will print out, text node is going to print out the scientist's name in the font UI font dot bold system font of size 10. Now you might think, well, that's going to be 10 meters high. It'll scale it down by 0.002. Why don't I just use UI font of size 0.005 or something really small? And the answer is because it causes serious problems. SceneKit does not like extremely small UI fonts. It's render a large UI font and scale it down. You'll cause massive problems otherwise. Anyway, that's the title of this person. We're now going to say title node dot pivot on top left. So it'll position from the X0, Y0 edge. We now move this around correctly in more sort of UIKit natural positioning. Next, we're going to bog down, Andre. What we're going to run the code, and we'll know then if the extension is correct or not. Okay, that's the easiest answer I can give to that at this point. Pivot on top left. We're now going to say our title node position X, which will be 0, 0 by default. We're going to modify that, so we're going to add to it the float version of our plane width divided by 2 plus spacing. Now remember, this plane here is the size of the image. So if it finds a, was it 5 and a bit cm wide, plane width will be 5 and a bit cm. But we're positioning from the center of that thing. So R00 is the center of that 5.5. So we're going to add half to get to the right edge of the picture, this way for you presumably, this way of the picture, and then add a little bit of spacing so we're off just the edge of the picture, like that. Then the title node, dot position, dot Y, we're going to add to that the float of our plane dot height divided by 2. So again, we're pushing up to the top of the image, like that. And now we're going to say plane node dot add child node, title node. And hopefully, in theory, if I haven't muffed things up too badly, we can try and run that back in a real device and see actual text. Let's find out. I press run, unlock my iPad, gone to sleep again. Should I put over here? Where are you? QuickTime. Okay, so hopefully, let's see what I screwed up. If I bring in, I want you over here. Oh, look at that. So we're now seeing Ada Lovelace printed out. You can see it's in 3D space, which is fantastic. It's aligned nicely to the top of the thing. It's to the left of it, so you can see, if I use my mouse at the same time perhaps, or my finger perhaps, there we go. This is a bit confusing. That little gap there, that's a spacing thing we added. So it's going to position it by 0, 0 as the default is here. It'll add half to the side, like this. Then add a little bit of spacing to push it apart from it. Otherwise it kind of butts up directly against the image, which doesn't look too nice. Like that. So, that is working quite nicely. Good job. Okay. Put that down again. And stop running that. Okay, so far it's looking pretty nice. Next we're going to add the bio text below. So that sort of one line of Wikipedia stuff, we're going to put that directly below. So I'll make a bit of space. And this is very similar code now because we've got this nice text node method. We're going to say let bio node is a new text node. Come on, code completion, text node. There we go. The string to be scientist.bio. Our font's going to be UI font.system font of size. Come on, code completion. So slow right now. Of size, and I make this 4. So a lot smaller, but still a reasonable number. Again, don't go from 0.2 or something because it just won't work. Anyway, this time though, we're going to pass in that max width value. So it will cause this thing to wrap at a certain point. give us multiple lines of text. We're going to pass it 100. So wrap in 100 points of space. This thing will also pivot on its top left, like that. So we can position it below the previous text node and to the right of the picture, like that. And then we'll do bio node dot position dot x plus equals, sorry, the float of our plane width divided by 2 plus spacing. The same thing we have for the title up here. That just means get the size of our thing, half it so it goes to the right of that thing, and add some spacing. So it'll sit to the right of the picture again. But for the Y position, we're not going to use plus equals this time. We're going to use equals directly, because we're going to say it is our title node's position dot Y, wherever the title node's placed, minus title node dot height. And this thing here, that comes from our extension to do the height. So it'll say move it below the title node, then add some spacing, like that. So position to the right of the picture and below the title node. Then we'll say our plane node dot add child node. Come on, hurry up, title node. I'm really hoping Apple will announce a new iMac Pro this year, because I'm very keen to buy one at this point. So that adds a new bio node as well. Let's press Command R again and try out. Let's try Einstein perhaps. Let's see if I muff that one up somehow. Come on, Einstein, you're up. Oh, that's not working at all, is it? See? No bio node. Okay, let's look where we went wrong with that one. Let's try and see what we screwed up. Oh yeah, bio node, not title node. My mistake. Don't do that. Don't make my mistake. My mistakes. Do better than me. Let's run it again. It's building very slowly. Annoyingly, OBS, the YouTube streaming stuff, really hits the CPU hard. I think adding in the QuickTime screen thing isn't helping either. There we go. Oops, what about it? There we go. Albert Einstein, 1879, 955. And again, it's in 3D space. You can move him around if you want to. He's just there being Albert Einstein. Okay, fantastic. That is coming together nicely. Okay, we're going to add one more thing because it is already 7:05. We're going to add those flag pictures below. I'm going to say here in our assets we have Germany, Italy, Poland, Serbia, and UK. We're going to add that below the person's picture. And this is where that pivot on top center becomes useful. If you want to center align it with that picture node above it. So say if you control it Swift, in here, below bio node, we're going to say let flag equals a new SCN plane. Oh, that's going in the way. Sorry. I'll try it again. Sorry, I didn't realize. I'm being silly. QuickTime. There we go. Sorry. Thank you for pointing that out, Robert. I'll try it again. When it compiles, of course. Come on, Xcode. It's really struggling to compile thing right now. I'm not terribly sure why. Come on, you. There we go. And there's Einstein. Beautiful. Hopefully you can see that nice and clear. Einstein. Go over there, Einstein. Great. Okay. That's our text wrapping working nicely, hopefully. Anyway, back to the flag. SCN plane. This thing is going to be the same width as the reference image. So it will match up the size of Einstein. The flag will be the same size below. So we'll say our width is image anchor dot reference image dot physical size dot width, like that. And for the height, we're also going to say image anchor dot reference image dot physical size dot width, because it's the same thing, but I've made the height be a multiple of the width. If the width is 800 of the flags and the height is 500, so what we can do is we can take our width, divide it by 8 and times by 5 to get the correct height for this thing relative to the width. The Mac is actually very, very fast. It's a maxed out 2016 MacBook Pro, But you've got to keep in mind, OBS is also maxing out the CPU hard. Streaming this to the internet takes a lot of work, as does streaming my iPad, as does trying to build Swift. So there's lots going on. That's why it's slow. Anyway, so that is our flag node. And what I want to do this time is say, actually, you want to have an image. And just like colors, we can just throw an image directly in there and SceneKit just figures it out. It's absolutely amazing. We can say our flag's first material has a diffuse contents of the UI image named scientist.country. So if they're from Germany, it'll find image name Germany, put that into a UI image, put that into the diffuse contents for our flag. That's, of course, once again, model data. It's geometry. We're going to wrap that inside a SceneKit node to place it in our scene somehow. So we'll say, let flag node is an SCN node, geometry being our flag. And then flag node dot pivot on top center. So we can align this centrally to the image above it, but move it below the image very easily. So we'll say now flag node dot position dot y. The x is fine because it's 0, the middle of the thing above it. Minus equals, so move it down the screen somehow. In our case, it's going to be the float version of the plane's height divided by 2 plus spacing. So remember, it'll be creating the middle of the person's picture. So we'll take half of that person's height to move it down to the bottom of the picture. Then have the spacing below. And then, plane node dot add child node. Come on. I'll just type by hand. Child node is flag node, like that. Boom. And that might, in theory, finish our project. Let's find out. Oh, build failed. What did I do? Oops, yeah, sorry. Typo. Oh, seems to work. Let's try again. And I'm going to bring out. Who should I bring out? Which science are you're not used yet? Let's bring out Mary Anning. All right, Mary, you're up. Bada boom, bada bing. So now you can see we have a UK flag below her, Mary Anning, her bio, and the whole thing now is in 3D space. It's all attached to that node. Move her around freely. Let's bring in Nikola Tesla. Boom. Smart dude. Here is Ada Lovelace. And we'll do one more. Here is Albert Einstein. Perfect. Okay. So you can see it's actually all working really nicely. You can pick it up, move around if you want to. It's all working in real 3D space. It's absolutely amazing. All being done for us by SceneKit and ARKit with a dash of code. Oh, in the way again. Oh man. This is the problem with the 15-second chat delay. Well, you know what? You missed it. It was absolutely amazing. You totally missed it. Nah, I'm just kidding. I'll do it again. I'll do it again. One last time. This time with the iPad actually visible. Are you building Xcode? Are you building? Fine. Okay. Let's try again. All right. This time, try again. Boom. Okay. I wasn't lying. It is real. It's Ada. Let's move her out and bring in, who did I do? Mary Anning, perhaps. There we go. And let's bring in it's Tesla. There he is. And if I pick up old Tesla, you'll see it all works very nicely in 3D space. Looks great. There we go. So, all done for us by SceneKit, sorry, and ARKit with some Codable too. And that is 7:10. That ends our project. If you have more questions, now's the time. And this can be, of course, off-topic questions too. And you can see there isn't really a lot of code here. What is this? This is like 149 lines of code. So yeah, it's under 150 is exactly correct. And that includes, white space, includes this big comment at the top and similar. So yeah, it's pretty small stuff, I think, quite frankly. You can get a lot of work done in not much space. So yes, there you go. All right, anyway, if you have questions, of course, now is the time to ask your questions. Go ahead. Let me know. Drinking wine, but I really ought not to be because I'm doing the Swift Over Coffee podcast next. In fact, as I have my coffee here, it's almost cold actually. I should probably drink this instead rather than the wine. Yes, of course, fully on brand with my coffee mugs. Guillermond asks, do I still have combo deals? So I've had bundles for a while, but they are only restricted to certain books because each bundle is a new product in its own right. I have to upload the books in there by hand. So folks tell me, oh, how can I buy this and that and this and that? And the answer is you can't, because it would mean having 100 different kinds of bundle. Each updated to Swift 5, Swift 6, Swift 7 by hand. It'd be extremely painful. So I'm afraid there are no custom combos, only the official bundles, which include the Power Pack and the Platform Pack for now. Is there any way to show websites? Yes, so you've got to use UI WebView. It's a real shame because, as you said, WK doesn't work. It's an external process, so you can't hook that into your app. You've got to use UI WebView, and it's a real shame. And I mentioned that in my NS Spain talk last year, teaching Swift at scale, because UI WebView is deprecated now. It's going away at some point in the future, and it's the only thing that works in ARKit at this point. I'm hoping this year is going to be better, but right now you have to use UI WebView and haven't got any other choice. Hey, Noble Brown, I remember you. How are you doing? Reflecting me, possible to pull data in. Yeah, it's JSON. You can pull it from wherever you want to. Absolutely wherever you want to. It's just your code. Do what you like. Emin, would recommend Mac Mini. The new Mac Minis are incredible. They're really, really powerful. Oh, Mark, you're most welcome. And when the dogs come back, if they come back, I'll give Luna a treat this time because she didn't get one last time, so she can have a treat this time. The new Mac Minis are extremely powerful. I am planning to switch to a Mac Pro because I'm tired of. In fact, I don't know if you noticed, I did this thing for April Fool's Day this year, which was Apple internal mode for Xcode 10.2. You had to make a project called Apple Internal, and it enabled really mean-spirited error messages inside Xcode. And to do that, to modify the error messages inside Xcode, I had to build Swift from scratch using the toolchain builder. So I put that toolchain into Xcode to modify the messages. And annoyingly, the toolchain builder in Swift is designed for their CI bot to use, not for humans to use. And so every time you do a new toolchain build, it builds Swift from scratch, which takes about 2 hours. And it was very, very slow. I'd make a small typo or try and change something, it wouldn't work. I have to then go and rebuild everything from scratch, another 2.5 hours every single time. And that's on a quad-core i7 MacBook Pro, right? So it really, I wasted so many days building Swift again and again and again to get that April Fool's joke exactly right. So yeah, don't do that. I'll be buying an iMac Pro as soon as they re-release the updates. I think this is day 500, I think, since the iMac Pro was last bumped, like majorly bumped. So I'm hoping this year, new iMac Pro, a new iMac plus a new MacBook Pro will keep me out for another year or so. It'd be nice. Anyway, my question was Mac Minis. Yes, they're very good. They're very fast. In fact, probably faster than my MacBook Pro. Because the problem with the MacBook Pro is the heat dissipation rate is very, very low. It barely goes to turbo boost in the Intel CPUs. This is why folks put it into the freezer and similar. So it can run faster. So even though it's technically a very fast device, the fans are on permanently sometimes. It's not great for real performance. Question Elias, minus min. Yeah, probably. I'm doing this all from memory, quite frankly. So you're almost certainly right. What do you want to remove? You want to remove... you want that? Is that what you're saying? That? Possibly. Yeah, I do my best to do it from memory, but it's not terribly easy, to be honest with you. Yeah. Anyway. If you clarify what code you want, I'll type it in and press run, and we'll know for later on. And I'll commit the right version to GitHub. Just tell me what you want to put in there, and I'll put the exact code you want in there, and we'll try it out. Pawan Kumar asks, which software do I use for video recording tutorials? I use ScreenFlow, and it's okay. I mean, that's all I can say about it. It's okay. It's quite good. There are so many problems with it that they don't seem terribly keen to fix. Every year they release updates with some tweaks. Like this year they added a stock library like everyone else in the whole world. Great, I've got an Adobe license for that. I don't need your stock library. That's your major improvement. It's not really helpful. So it's annoying, but it's as good as it gets for me right now. Can you do compilation refresh with background URL data? Oh, on Sundays? Possibly. The problem with WatchKit is that launching it from the simulator is very annoying. It often doesn't work, so we kind of bounce around a little bit trying to get it work, which is really annoying. Certainly when I'm doing, WatchOS development. And the problem with doing it live is it's that extra element of failure. I mean, right now I'm using an iPad talking to QuickTime, syncing to my screen with the camera and ARKit plus streaming. So there's a number of possible points of failure, and it has worked this time, fortunately. But the WatchKit thing fills me with fear, 'cause even though I love making WatchOS apps, it's so much fun to work with. That risk of Xcode saying, "Meh, sorry," it's there, and it haunts me a little bit. So we'll see. Maybe one of these weeks we'll give it a try with the epic proviso up front that it might go wrong. Matt Morris asks, iPhone does a better job handling multiple images. So I've got the older iPad Pro. I've got a second gen iPad Pro, not a third gen iPad Pro. I suspect the third gen is better, like the iPhone is. It is better. It'll do 2 or even 3, I believe. The iPhone will do when it works. I didn't use it here because it's a core motion bug which hits it sometimes. It's really annoying. And the app runs, but then you see these core motion crash errors appear in Xcode while the app runs, which isn't very good. Anyway, to increase performance, I think the key is to keep the number of images recognizing low. Don't try and add too many. I think 20 or so is the maximum really you're looking at to be efficient. And if you wanted more than that, then you have to start enabling and disabling it at various times. For example, if you're doing a museum app or something like that, you might say, "Oh, you're in room 302. Activate room 302 pictures." And that could be select the room in your iPhone, or use iBeacons, detect it internally, and say, "Oh, you're in room 302 now." Just spot the iBeacons locally. So iBeacons plus ARKit. I mean, it's all of Apple's buzzwords, right? That's a good thing. Would it be dumb to see Swift as Python with braces? They're very different languages. They're very, very different languages. I mean, like trying to do an enum in Python. I was teaching some kids at my daughter's school. We had Swift playgrounds, and they made a really nice little app for doing state of an app they're making using enums. And I was okay, let's try and put that in Python, see how Python's different. And like, how the heck do you make enums in Python? Turns out, really bad. There's really, really bad support for enums in Python. It was a bit of a hack we found in the end to get enums kind of vaguely working. They're very different languages, and Python has things Swift doesn't have, and Swift has things Python doesn't have. But right now, I'd much rather be writing Swift, quite frankly. Any chance seeing state machine to SpriteKit? There's a chance, but I wouldn't rate it terribly highly. I've done SpriteKit twice. It's quite popular actually. People seem to like SpriteKit. Might do a third SpriteKit one of these weeks, perhaps. Anyway. Emilio, how to stop a physics body immediately? Yeah, I'd use velocity. There's no other way. I think the velocity nixes it. You could remove the physics body and re-add it after you set velocity to 0. That might do the trick. Who knows? Am I going to post apps to the App Store? No, I'm not. All the apps I post on Sundays are not on the App Store. In fact, any of my books aren't. So if you see anything on a Sunday stream or any of my books, take the code, put it in the App Store, release it. I don't care. Fill your boots. Do what you like. Is it a good idea to use page view? What's a page view? You mean a UI page view controller? have to clarify, and then I'll try and answer. Reflecting me, you want to use Python to upload the App Store? No, don't do that. Use Swift. Elias asks, is it possible to use AR images downloaded and not putting in assets? You know, I don't know. I suspect this thing gets built somehow. If we looked at products and open this thing in Finder, I suspect we would see in here. Oh, dogs are back. Now, you had a treat already. Mark Moykins got a treat for Luna. Where is Luna? Luna? You have one already. You have. Don't sit down for me. You have one already. Someone bought for you one already. Luna gets one from Mark Moykins. Anyway, in the app, in here, you'll probably find that stuff is built carefully. There we are, assets.car. It'll be in there somewhere, I expect, compiled out. So if you want to dig through there and try and find it, please do. But it'll be compiled, optimized somehow. So I'm not sure you can. I haven't tried it personally, but I'll be careful. You might have to build NX code first, then put that into your server, perhaps. Any more questions? I hope you already liked the video, by the way. It does take me quite a while to prepare these things. So liking it's the least you can do. Anything special for the 100 Days finale? I don't want to spoil it. It's not going to be another project on day 100. It's going to be something else. There will be certificates involved. And there will be 3 different certificates, depending on how well you do on the last day. So you'll have to brush up your skills a little bit to ace the last day. We'll see. Have I ever tried using real-time language translation using AR? No, I haven't. Sorry. Look, you've had one already. Where's Luna? Luna has not had one. You had one already. Luna hasn't had one. So yes. No, I've never done language stuff in ARKit. Sorry. Audio files of 1.8 gigs. Wow, that is serious sized audio. I mean, keep in mind my Unwrap app for iOS, which is on GitHub right now. It's in its 6th test flight build now. It teaches you Swift on your iPhone, your iPad. That has, I think, 99 videos, and the entire thing's maybe 140 megabytes. And they're videos lasting 1 minute each. Plus all the code and all the assets and so forth. So you've got 1.8 gigs of audio. You've already used that really uncompressed audio. Consider using AAC or lower bit rate or 1 channel rather than 2 channels or something else. You keep going back, Aria. You've had your treat. You've only 1 super chat for you. Don't sit down. Nope. The other one's for Luna, not for you. Right. Is my code for advanced coordinates on GitHub? No, it's not. It's like 6 different things. It wouldn't really make sense making it into one project. So no, I'm afraid it isn't. Okay, UI page view controller 100 items. Yes, that's absolutely fine. The way UI page view controller is, it only keeps 2 or 3 things in memory anyway. So as long as your back-end model, whatever it is you're showing inside the page view controller, is loading and unloading things sensibly, then yes, you can do what you like with 100 items or 1,000. It doesn't really care anymore. It's fine. What's next after 100 Days of Swift? Well, I have about 3 weeks between then and WWDC starting. So what I'd like to do, I haven't announced this publicly yet, so you'll kind of get a sneak preview. What I'd like to do is carry on making videos for the rest of the Hacking with Swift projects. So we get through all 39 as videos, and with challenges, quizzes and so forth. And then release that as a student and teacher package. So folks who run classes teaching Swift can say, here's all the things you need. Here's PDFs of tests you can hand out to your students, all the videos, all the source code, everything for one extremely low rate. So they can teach Swift to schools more easily. Because as much as I love Apple's Everyone Can Code initiative, it kind of maxes out at a very small level. It doesn't go very far. And there's a big gap between that and real iOS development. So I kind of want to pitch my thing beyond Everyone Can Code with those tests as, you know, PDFs and more for students at high schools and universities to follow along with. That's the plan. We'll see if I have time for that, because there's other things I want to do as well. I'm always trying to cram things in. We'll see. How can we know UI view is created? That is view did load. View did load is when your UI view has been made. And when I run workshops and tell folks to stop putting UI view code creation code inside view did load, they look at me like I'm an alien. Of course you start making your view stuff, your stack views, not image views, inside view did load. They're convinced that's the right way of doing it. Because I've seen so many other tutorials doing that way. And like the clue's in the name, right? View did load. The view has finished loading now. What do you want to do? So in theory, load view is where you want to do your view loading, and view did load is where it's finished loading. And anyone who says otherwise really needs to go back and read Apple's documentation. An hour-long audio is still perfectly compressible, Anand. You know, you can crush that down using AAC, or someone recommended Socks already. Socks is very good for that. Get it way, way small in AAC. Particularly if it's audio, if it's speech. Speech can come down to, you know, 64 kilobytes a second at AAC and be very, very high quality still. Elias asks, do you know any performance concerns regarding rendering and text drawing? Yeah, there's stacks of performance concerns. Yeah, crikey. I mean, you mean in SceneKit directly, or just in general? I mean, if it's general, there's loads of reasons. I recommend you watch one of Janina Coutin's videos. She does some really good UIKit high performance talks at conferences. She did one at UIKit at UIConf last year. She did one at Swift and Fika last year. She did one at Mobilization last year. And they're good talks. The great talks are really good, because she's ex-Apple. She knows what she's talking about. High performance UIKit is her bag. So if you want to see stuff, do you want to do that? Gary Hansen asks, so today, good. Go ahead and make PRs. Good like that. Unwrap is an enum, but it looks like a struct. So it's a fairly common technique. If I try and open up the source code, someone else can look at it as well. Unwrap.exe workspace. Let's open that in Xcode so you can see what it looks like. Here. So you'll see unwrap.swift contains a few sort of constants for stuff. Only a handful. And it's an enum, not a struct. That's what this question's about. And the reason for that is because if it was a struct, it becomes possible to make an instance of unwrap. And this thing is really just static constants. You know, what is my default font size? What are my chapters? What's my app URL and similar? So it can be used everywhere in the app. It's just there to hold some fixed data that isn't changing anywhere as fixed constants. If that were an enum, I'm saying you can instantiate this. You can make an unwrap, make 5 unwraps. And that doesn't make sense. It's conceptually wrong. Making an enum stops you from doing that. There are no cases in here. It's a non-instantiatable constant holder. That's all it's doing. Good question, though. Piotr asks, MacBook Air 2018 or MacBook Pro 2015? The 2015 MacBook Pro, it's getting on a little bit long in the tooth now, I agree, but it's still the finest laptop any company has ever made, ever. It's amazing. It's highly recommended to use a 2015 MacBook Pro. They're gorgeous, amazing devices, and I wish we'd get them again, but we won't do because, you know, Apple. you'll find even that old one has a significantly faster CPU than the MacBook Air. Even like this year's MacBook Air, the newest MacBook Air you can get your hands on had a much slower CPU than MacBook Pro from 2015, because the MacBook Air is designed for thin and light, web browsing and similar, not for Swift. Even though the Airs are lovely devices, I love the colors. I love to get my daughter a gold one. She can't use Swift on it; it'd be too slow. So yes, if you have a choice, I'd always choose a MacBook Pro. Even a slightly older one is better than MacBook Air because it's designed for more stuff. Pawan asks, what does super mean? So all the classes we have inside our view controllers, if I bring up like this one here, all inherit from UI view controller, which is the parent thing inside UIKit that means give me effectively a screen of data. And that's great. It handles things like rotation, handles things like state restoration, memory warnings, and similar. And we subclass that to have here, in this case, Tour Item View Controller, our custom screen. Now, when our custom screen is loading, we're doing some work here to render that correctly. But the parent class, UI View Controller, also has some work to do, potentially. In this case, it doesn't actually, but it might do. So we're saying here, the first thing you do is super our parent class, UI View Controller. You go ahead and run your view.load code now before me, and when you're finished, I'll do my custom configuration. So you'll see super an awful lot. That's what it means. Mehdi Aslani. How to implement a scene view in UI collection view. That's a very specific question. Not really a great thing to do right now. How do we unwrap on the phone? You can use TestFlight. I posted a link to TestFlight on Twitter yesterday. Please do. I'll try and find it again. Testflight.apple.com. There we go. That's the link. Boom. That lets you join the TestFlight beta. You want to install TestFlight from the App Store, then go to that link on your iPhone, and you can join the open TestFlight beta. There's something like 2,200 people sign up now, 2,200, which is great. It's amazing. Get lots of good feedback from that. It's open to join. Use that link, download it, try it out. You'll get any updates as they happen. I might do one more, maybe one last little tweak here and there. Grab that, but also go to GitHub. It's on GitHub.com. We can grab it from there, push it right to your device. And if you do that, it has the advantage that you can send changes in. You can give me PRs, which I love. I've had some great PRs recently, fixing some really good problems. So yes, if you want to send in your pull requests, please do. You want to go to github.com/truestraw/unwrap and grab that. So recommended very much. You can see there's some PRs waiting right now. Yeah, look at this. 4 PRs to get to it. As soon as I finish with this, I've got a call afterwards, and I've got a podcast. Maybe tomorrow I'll get those PRs and get them all merged in. I might do one last TestFlight build with those changes. We'll see. Green Pulp. Will I review the architecture or code of Unwrap? What, as a Sundays stream? I hope not. That'd be really tedious. Like, here is the view controller. It's like, oh, no one cares. You can see a few things like from my code pretty quickly. If you look at, say, the learn view controllers over here, you can see I really try and keep my view controllers short. This one's 59 lines, and that includes, peeking and popping here. That's all peek and pop. So you can sort of press hard on things to show them up. There's coordinators, there's table views. I really like keeping my things as short as possible. So once you subtract code, comments, and white space, that's about 45 lines of code probably. For me, that's a good old long view controller. Anything more than that gets a bit long in the tooth. So anything past 100, I start sweating. So here is the practice one. Again, it's super short. It's like 42 lines of code, including white space and comments. So probably about 30 in total. Super short. That's how I like my stuff. So I could do a discussion of this it'll be a bit tedious, I think, to go through that in detail. But if you have questions, if you want why to do this thing in there, why to do that thing, then you can ask that if you like. I can have a go at answering on the fly. We'll see how we do. Anyway, if you fork from GitHub, you can go ahead and fork it here. Yeah, 1,013 stars. I've passed 1,000 stars. Amazing. Good. Thank you very much for that. Go ahead and fork it, grab it, modify it, open up PRs, file issues if you want to. Right now, I've connected Bitrise, and Bitrise complains about every single build. I've got no idea why. I normally use Circle CI. I'm trying out Bitrise. I don't know why it's complaining. So if you do a PR and it complains, ignore it. It's just Bitrise being weird. Anyway. Right, questions. Blah, 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 blah. Probably not. No, I'm afraid, mate. I won't be doing that. Yes, it is open there on GitHub to go and grab. There are lots of ways of dumping out data in Swift. Everyone floats your boat. I think not enough folks use dump. Dump's really good as well, because you can get that back to you as a string, which is really nice. But I normally use print. I'm quite lazy. In fact, I made a GitHub, again on GitHub, a Xcode source editor extension called Sharpshooter, which is like the laziest possible debugging. It inserts print statements for you. If you're trying to figure out why things are broken, it prints out when it entered in every method. You can track the flow of your program while you're debugging, and one click adds them all, and one click removes them all as well. So it's really, really fast to do that kind of thing by hand. Anyway. By the way, one of my hopes for this year, Xcode 11, I hope we'll see real Xcode extensions, not the very simplistic, boring source editor extensions, which have barely been used. I made one. There's maybe like 20 in total, maybe in the world. I'm hoping this year we're going to see proper Alcatraz-style modify Xcode extensions. I reckon this is going to be the year for that. We'll see. We'll see in 6 weeks or so. 5 weeks. Getting close. Looking forward to it. Any more questions? That is 20 to 8. I'll see if I can attract Luna, because Mark did very generously give me $10 for dog treats, and Ari had one already. So if I'm lucky, if I shake the bag enough. There we go. Immediately, Luna arrives. Come on, you. Come say hello. Whoa! Oh, you big lump. And you're wet too. Why are you wet? Oh, you're wet. You've been outside, clearly. Obviously, it's raining outside. Anyway, this is Luna, our #1 earlier Samoyed. She has earned her treat. Go on. There you go. Good girl. You're a good dog. There you go. Alright, you had yours already, sweetheart. You had yours already. Oh, wait. Oh, yeah. Swift event. I'm running a Swift event soon. So it is hackingwithswift.com/live. 8th and 9th of July in Bath. All profits go to charity. It's going to be awesome. And it's going to be 2 days event with great speakers on day 1 and then hands-on tutorials day 2. Lots and lots to learn. If you intend to come, please buy a ticket now, because we're trying to splash out buying, speaker flights and hotels and stuff. So we're losing money right now because we haven't sold the tickets yet. So I'd rather you buy them now rather than in 6 weeks' time or 10 weeks' time, whatever, because it helps us get the money now rather than later. It's better for my credit card, trust me. So yes, Ara, you have one already. Both of you staring at me. You've had one already. Third speaker. Yes, the third speaker is going to be Daniel Steinberg. I should announce him today, really, but I've been so busy doing other stuff. Daniel Steinberg is an amazing, incredible storytelling speaker, and I'm really looking forward to seeing what he'll deliver for us in July. Why doesn't Apple make me work on Xcode or Swift? Oh, I honestly, they hire some wonderful engineers, really incredible. I've had the privilege of meeting many of them, and they're just so switched on, so capable, so friendly as well. They're really quite personable people. So I've had the privilege of meeting quite a lot of their engineers, and they're wonderful. You know, they're way above my level. You got to keep in mind that Apple, you know, doesn't want a general developer working on Core ML or Create ML or ARKit. They want the very best they can get their hands on in the machine learning space, in the AR space, and similar. Because some of the things they're doing with Create ML are really very impressive. So I suspect there's a whole raft of PhDs behind that team doing some serious mathematical work. And that's not my kind of thing. You know, I think I'd be a very good developer evangelist. If they want to hire a Swift community evangelist, they know where to find me, right? But right now that role doesn't exist, so it wouldn't happen. Also, I'd have to stop writing. You know, I quite enjoy doing live streams and writing books and speaking at conferences. I'd really miss that. You know, I really enjoy books and articles and stuff. So, really problematic. We'll see. Anyway. Hey, Aria, come here. Let's show you off. Come here. Come on. You're not getting a treat. Come here. Come on. Not you. You have a treat. You have a treat. Come here. Come here. Don't growl at me. Don't growl at me. Oh. This is Aria, the new dog. She had a treat earlier. And she is so soft. And she's wet too. Excellent. I'm glad I have two wet dogs on me. She's our new arrival. She's lovely and friendly. She likes sleeping in our bed, it turns out, and wake up in the morning, which is lovely. But she's super friendly. And likes treats. Anyway. Oh, yeah, I forgot to say I'm wearing a new hoodie today. This one, you can barely see it because the text is grey on a black background. If you look carefully, it says Defcon Code. This is a wonderful initiative I found on YouTube. Teaching folks programming in Swift using sign language, which is wonderful. Because, you know, representation matters. Getting folks out there and saying, hey, I've done this thing. I want to pass on my skills to you. Go and check them out. They're on Twitter as Defcon Code. Will I do tutorials on generating Swift code with sorcery? I've done that already, actually. If you just Google up hacking with Swift sorcery, boom, there you go. Long tutorial here using sorcery to do stuff. Right there, as an example. So yes, done it before. Read that. That was like a year ago. Wow, almost exactly a year ago. Cool. Junaid asks, can I learn iOS games without any knowledge of physics? Yeah, it's fine. I mean, keep in mind that SpriteKit doesn't have its own physics engine. SpriteKit just wraps Box2D, or at least did. I should presume it still does. For its physics engine, right? They don't code it by hand. They just use somebody else's because it's maths. It doesn't change it very much, right? Yeah, by all means. I think the first SpriteKit Sunday stream I did, we used physics. I don't know the second one. What was the second one we did? I forget. Probably physics there as well. We can go to the GitHub thing and find out pretty quickly. Oh no, it wasn't. The second one wasn't physics. The second one was something else. So on Sundays. And you'll see in here, it was called OMG Marbles. There you go. Full month ago. Grab that. That's physics. It's trivial to use in SpriteKit. If you follow the 100 Days of Swift project at hackingswift.com/100, quite a few of the projects in there also use physics as well. It's really easy to do, actually, so you'll be quite surprised. Question, how can I download the Spot Scientist app? I haven't pushed it to GitHub yet. I'll push it to GitHub shortly. Once I finish the stream in a few minutes, I'll push that code to GitHub, and you can download it and try it out. I have no books in SceneKit, I'm afraid. Sorry. Do I have plans for new books? Yes, I've got loads of plans for new books. I'm really annoyed with myself. I've got so many big plans I want to do, but I'm juggling a number of things right now, like the conference, like the 100 Days of Swift, like the Unwrap app, that my brain's full of things already. And imminently, you know, in the next 2 weeks or so, the 100 days finishes, at which point I'm free for, you know, 4 weeks or so, 3 weeks before Dub starts. I plan to do a heck of a lot of writing at that point to try and catch up all the things that have been in my head all this time. The big backlog of things that have been in my head. I want to try and get out there as fast as I can. So expect some things then. Probably not a new book before Dub though, because it's just too much to do. We'll see. Hi Sandeep, how are you? Okay, it's your last chance of questions. You have 5 more minutes or so, approximately, before I sign off and get on to the rest of my backlog for the evening. Hacking with PHP has not been updated for a few years now, I'm afraid. I don't update that book at all. Add some tutorial on API. Which API? How many tickets? There's no limit on tickets. So that's making some folks say, well, I'll wait a few weeks and then buy it in a month or two. You can do that. But if you buy now, it helps us spend more money now to get, you know, more things, more swag bags, more party, better speakers, or not, more expensive speakers perhaps. Because, you know, I'm looking at some folks from LA, for example. They're expensive to fly out. I'm like, well, can I afford them or not? I don't know. If you plan to come, please buy your tickets sooner rather than later. It helps us budget much more efficiently. API calls. Sandeep, that's not really a question I can answer. I just throw on API calls. That's not actually sensible. Any more questions, or are we done? If you have more, of course, you can always follow me on Twitter. I am twitter.com/2straws. You can go ahead and ask questions there. Boom. Or on the Slack channel. There's obviously I hang out there an awful lot. Other folks can answer there, hopefully as well, which would be nice. The invite for that. Let's have a look. Invite people. Share invite link, copy. I'll paste that into here so you can join the Slack group if you want to. Boom. Please make a network layer. We did networking previously, like in number 3 or 4 or so. It wasn't a network layer though, just some networking. There's a limit, right? You know, I've got an hour to make an app from scratch. Can't do too much work in that 1 hour, can I? I mean, I'm glad you enjoyed it. Go ahead, you totally, Emin, you can totally contribute to Unwrap. You're way good enough to contribute that app. So go and get it from GitHub. Don't use TestFlight. Get it from GitHub and build it by hand and then contribute. I'm looking at you. No pressure. A network layer that we use in all project, that's called Alamo Fire. I'm not going to make Alamo Fire in a Sunday's event. Okay, last chance to ask questions before I sign off. If you've not already liked the video, you know what to do. Please like the video. It helps other folks find it. It'd be nice. The more they like it, the more I can make. It's good for you, good for me. I mean, you've got to keep in mind, the way Unwrap's structured is, if you look at that, there's actually information on a thing, how to contribute. And there's things like, you know, if you want some easy things, just do this. Intermediate or advanced, do these things. And it's things like, you know, are there any postscripts we can add to the JSON? Are there any more solutions for free coding problems? Because the way the free coding lets you type in code to see if it's going to work or not, like do this thing in code. And of course I can't compile Swift locally. There's no Swift core yet, although I have filed a radar begging for one, like JS core. If you go into the Unwrap content directory, is it in here? Oh no, it's in practice, sorry, Unwrap activities practice, and choose free coding. You'll see it's basically a JSON file explaining free coding. And it's like, you know, here's your problem. Here are all the possible solutions that are valid for that answer. And if you can solve that problem using a solution that's not one of these things, and it's sensible, not, you know, weird hacksaw and like that, add it in, because it makes it more sustainable, more reliable for everyone else to use as well. You can see there's quite a few of these sometimes, like down here. There's quite a few possibilities of how you solve that. So if you've got a solution that isn't in there, by all means, add it. It'd be great. So yeah, and that requires almost no code. Recognize other images. So the problem there you've got is you're mixing and matching what you're trying to do. Image tracking is one set of iOS, and model recognition is another set. And I don't believe they mix, that I know of anyway. So no. How often do iOS devs need to build on building authentication without using Firebase? I don't know. That's an odd question. You mean like who are aspiring for work? Like, you know, interview preparation, probably not that much. But at actual jobs, authentication is a pretty common thing to want to do. Ideally securely, obviously. You know, don't store passwords locally, that kind of thing. Okay, I think that's it for questions. I've kicked you about Unwrap. Please go and download Unwrap, which is great. Come to the conference. Go to 100 Days of Swift. Follow me on Twitter. Like the video. Subscribe to the channel. That's all my plugs, I believe. If you have any more questions for me, use Slack, use Twitter, use something else that is not YouTube. Otherwise, I think I'm back next week. Now, last time I was away on holiday, so I completely forgot to mention that last time. This time, I'll check now. Yes, there's a Swift on Sundays next week. I don't know what it's going to be yet, but it'll be new and fun, and hopefully another app from scratch in the same sort of 60-minute, 90-minute time period. I will see you then. Thanks for coming.